Hello again, everybody. This is the Space News by SpaceIndustryNews.com. My name is Will. Today we're going to be talking about a Soyuz rocket that successfully launched, NASA's Parker Solar Probe, and how it made its first pass by the sun. MIT says that existing laser tech could attract alien astronomers. Holy cow. And Indian scientists discover ultraviolet wings in the Butterfly Nebula. So let's get at it, folks. Let's get into some space news. Right over the weekend, Russia completed its second successful Soyuz launch since the October 11th failed crew launch, with the liftoff taking place on Saturday, November 3rd at 11:17 p.m. local time, and the launch from a pad at the Plesetsk Cosmodrome, located about 500 miles or 800 kilometers north of Moscow, put a navigation satellite called GLONASS-M into orbit. A Soyuz 2.1B rocket was used during the launch, and that's the same model as the Russians' most recent launch, and a variation on the model used for crewed flights, including the October 11th failure. According to a statement released by Russian space agency Roscosmos, the satellite deployed successfully after the launch and began communicating normally with Earth. So everything's good. The thing's up there. It's floating around. They're sending messages back, sending back signals, and pinging each other. And the launch came just a few days after Roscosmos completed an investigation into the October 11th failed launch, which sent a NASA astronaut and a Russian cosmonaut plummeting to the ground, and the investigation found that the abort was triggered when a faulty sensor caused a strap-on booster to separate incorrectly and hit the main booster. Must have been terrifying for those people. And Roscosmos has said that its next flight of the rocket model that failed, the Soyuz FG, will occur on November 16th during a cargo launch to the International Space Station in preparation for the system's return to crewed flights on December 3rd. And speaking of tech... Wait, were we speaking of tech? No, we were talking about stuff that got shot into space. Now, NASA's Parker Solar Probe just made its first close pass by the sun. One of humanity's newest spacecraft faced a harrowing test on Monday night, November the 5th, darting about 15 million miles from the surface of the sun. Must be friggin' hot up there. I mean, come on, that's pretty close to the sun. And the spacecraft is NASA's Parker Solar Probe, and it launched in August with a daring and crazy mission to study the star that shapes us, the star that we call our sun. And it's flying close to the sun on a course of 24 loops around it, and the first of which reached what scientists call perihelion, Perihelion. That's the closest approach moment, and that happened on Monday at 10:28 p.m. Eastern Time. There won't be much to get from this pass by. There's not going to be much to watch or listen to, and throughout the next few days, the spacecraft is it's floating on its own, man. That's because the sun is such a powerful source of radio wave light that it drowns out the spacecraft's communications with Earth. It scrambles all of our signals, and the spacecraft isn't just responsible for independently taking measurements during that time. It also needs to protect itself from the overwhelming and crazy amount of heat that comes from our star, the sun. And to do so, it tilts itself to keep its thermal protection layer shield between the sun and its very delicate instruments. So it's way up there, floating around the sun, making sure that all the little instruments, all the science that's in this probe isn't getting burnt by the sun. I mean, how crazy is it? You go to the beach, the summertime, it's 90 degrees, it's really sunny, you get a sunburn. Hopefully you use sunscreen and don't get a sunburn, but it's really hot. Could you imagine being that close to the sun? Could you imagine what it would take to not burn up? And this probe can do it. So hopefully we get some science from it in the coming weeks and months. Hopefully we get some really cool stuff from this probe. And we'll keep you updated. And we'll let you know if anything comes of it. But the first report back from this probe, it'll be just a beep. So somebody from the Johns Hopkins University of Applied Physics Laboratory has said, and they manage the spacecraft, so they just need to communicate. They just need a signal, and that's it. And once the engineers behind the spacecraft hear the beep, they'll have a better sense of what to expect from the first delivery of detailed science data, which is it's going to happen in about early December. And by that time, the spacecraft will already be well on its way out from the sun as it prepares for its next orbit. It will achieve 2 more perihelions in 2019. One will be in April and one will be in September. And then in next December, it will complete the second of 7 Venus flybys, which nudges the spacecraft's trajectory gradually closer to our star. And during the latest maneuver, the spacecraft will be traveling at more than 213,000 miles per hour. And at the end of October, the Parker Solar Probe broke world records for fastest speed and closest approach to the sun. So this thing is out there by the sun, orbiting it, going crazy. We're waiting for the blip. We're waiting for that one thing. And then there's going to be some science to be done. So we'll update you guys on that stuff too. When it comes time, when all that stuff happens, it's going to be a crazy time for some science in the near future. And from solar rays to ray beams to lasers. Some MIT scientists have said that existing laser tech could attract alien astronomers. And scientists all around the globe are working hard at new methods that might be used to detect alien life. But MIT has a different idea, and its concept is to use existing laser tech to create a sort of beacon that could attract any advanced ETs, extraterrestrial civilizations, that are actively searching for life in the universe themselves. MIT researchers say that current laser tech could be fashioned into a beacon, and aliens could be checking us out at any time, and the beacon would be able to attract attention from as far away as 20,000 light years from Earth. The research suggests that a high-powered 1 to 2 megawatt laser could be focused through a 30 to 45 meter telescope and aimed into space. Shooting a laser up into space, maybe somebody will see it. You know, somebody out in space already, some aliens, and they'll know where we are. And that signal could be detectable by an alien astronomer performing a survey of our section of the galaxy. And if the astronomers were in nearby star systems like Proxima Centauri, they'd have a good sample of our laser. This is kind of crazy. We're sending signals out there so aliens can find out where we are. Is that crazy of us? Is that kind of cool? I don't know. Will aliens find us? Will they be friendly? If they have astronomers out there looking for other planets and looking for other life out there, I mean, are they going to come invade us? Ooh, spooky. Anyway, this isn't about that. This is about science. This is about cool stuff that's going to be happening, because you never know. I mean, if there are advanced civilizations out there and they can see our laser that's pointed up at the heavens, so the message sent could have a data rate of a few hundred bits per second and could arrive at the distant planet in a few years. One of the researchers on the project says that most of the tech to do this exists now, and what doesn't exist could be developed in the near future. So we have all this stuff off the shelf. We could just put this stuff together, make a giant laser, and communicate with, with aliens out there. And potential issues with this plan include that despite that the IR beam is invisible, it could damage people's vision if they look directly at the beam. And the beam would have a flux density of about 800 watts per square meter, close to the sun's 1300 watts per square meter flux density. A safer location than Earth would be on the far side of the moon, and any distant astronomer looking at our section of the galaxy would also have to look directly at the laser to see the beam making detection of the beacon. Highly unlikely, say the researchers. So they have to look directly at this beam. They have to show this beam to an astronomer, and they have to pass right in the middle of the beam. Now, this beam is going to hurt your eyes if you look into it. Could you go blind? Possibly. Could the aliens go blind if they have same sort of eyes? By that time, I'm not quite sure what the laser beam would look like to them. But if you're going to look at this beam close to the Earth, you're going to get your eyes scorched out. So don't do it if this thing ever comes online. Seems pretty cool, though. If you think about it, how cool would it be to communicate with another life form via gigantic laser that's being shot out of a telescope? That's pretty neat. And speaking of telescopes, the Indian scientists discovered an ultraviolet wings of the Butterfly Nebula. Indian scientists have discovered large lobes and jets of cold gas around the Butterfly Nebula, and they found that this gas formation was caused by an event much older than the one which brought the remaining nebula into existence. Planetary nebula are structures that are formed during the last few stages of the lives of stars like our sun. So the astronomers at the Indian Institute of Astrophysics, the IIA, have, using a telescope on board the Indian Space Research Organization's ISRO AstroSat satellite, discovered large lobes and jets of cold gas around the Butterfly Nebula. They found that this gas formation was caused by an event much older than the one which brought the remaining nebula into existence. And the Butterfly Nebula is one object. It's named NGC 6302, and is located nearly 3,800 light years away in the constellation Scorpius. Many of the nebulae have strikingly symmetric shapes that need not be spherical. Sorry, I'm reading this, and sometimes you just don't read right. I don't know. Sometimes you just mess up, and that's what's cool about this podcast. It doesn't have to be perfect. We're all people here, right? So sorry about that. Let's get this thing some more science your way. So the NGC 6302 is a planetary nebula whose shape is similar to the wings of a butterfly, so it's nicknamed the Butterfly Nebula. And IIA's Professor Kamshwa Rao and their team have been investigating planetary nebulae in the ultraviolet light. Now, using the ultraviolet imaging telescope, the UVIT, UVIT, on the AstroSat, the first space observatory launched by India, they have imaged the Butterfly Nebula through the far and near with ultraviolet filters. Now, using these images, they have discovered that gas which extends the known wings of the butterfly out to 5.5 light years from the center, nearly 3 times of what is seen in the optical. So this is a new discovery because they use different imaging techniques. Researchers say, while arguing that the extended far UV light is due to cold hydrogen molecules in the gas present in the outers of the nebula. And they also suspect that these far UV structures of the nebula point to the possible presence of 2 central stars in the binary system that are bound gravitationally. And this has been published in the Journal of Astronomy and Astrophysics. So China unveiled on Tuesday, that's today, a replica of its first permanently crewed space station, which would replace the international community's orbiting laboratory and symbolize the country's major ambitions beyond our planet Earth. It's called China's New Heavenly Palace, and its 55-foot core module was a star attraction at the biennial air show. China, in the southern coastal city of Zhuhai, the country's main aerospace industry exhibition. And it